Following the recent video on the tree pipe problem, a number of you have raised concerns on the visibly bulging patched surfaces. This can be quite noticeable while looking from the side. I'm going to share some ideas on how we can mitigate that. We will also be taking a look at a different way of approaching the problem. Lastly, I will be discussing an interesting scenario where the tree pipe solution can be applied. I have posted a file in the description below. Feel free to download and follow along. Let's locate the patch feature. Right-click and edit. To address the bulge, one of the things that I did was to try to adjust the curvature weight. In the previous tutorial, I had left this at the default value of 0.5. Adjusting in steps of 0.1, I found that 0.4 was the minimum weight that I could apply and still get a patch to solve. At 0.4, the bulge does lower in height, but the depressions in these two areas become more pronounced. In the patch surface command, we do have the ability to introduce rails or guidelines, so let's try that. Roll the timeline to before the patch surface. Let's go to Construct, Tangent Plane. Click on this cylindrical face and select the right plane as a reference plane. With the angle set at 0, the resultant plane will be tangent to the cylinder and be parallel to the right plane. Create a sketch on the new construction plane. Let's select this curve and press P for project. Let's create an offset. Set the offset to 15. This will align the endpoints of the curve to the centers of the respective cylinders. Confirm the sketch. This will be our rail. Think of it as a scaffold on which the patch surface can hang onto. Move the timeline forward. Edit the patch feature. Click on the select box for rails and select the new sketch line. You can see that there is significant improvement, but it still does not totally remove the bulge. You can try drawing a line across in this direction to serve as a second rail. When I tried that, the surface quality was not the best. I will leave that to you to try. The main problem here is that the patch surface straddles quite a large area. We are simply asking the patch surface to do a little too much. In the previous video, I did mention that we can adjust the offset planes to minimize a patch surface. We can adjust the offset in small increments until a point where the patch surface actually fails. As the offset plane approaches tangency with the cylinder, the split face can no longer be resolved. Instead of adjusting the offset planes, what if we adopt a different approach and split the cylinders like so? At this point, I would like to thank Akash for inspiring this solution. For these two cylinders, I will be using these two sketch lines to split the faces. For the bottom cylinder, I will use a front plane. We will be using these arcs as profiles to perform the surface lofts. Remember to activate the Surface tab before starting the loft. As with the previous video, set both continuity options to tangent and align to surface. Go to Create, Patch. Uncheck the Enable Chaining option and select the 3 edges that bound the opening. In this case, it makes more sense to set the continuity option as tangent, as all the surrounding faces are essentially derived from half pipes. This gives us a very flat surface, but at the same time allows for a decently smooth transition. Let's move on to a more interesting example. Besides joining pipes with identical cross-sections, you can also consider applying the same workflow on pipes with different cross-sections. We have 3 different types of cross-sections here. These are extruded surfaces based on simple sketches. These fillets can be applied in the sketch. You can also apply them on surface bodies using the same filler command that you would normally use on solid edges. The fillets help to smooth out the lofts that we are going to perform later on. At the same time, they are also a convenient way of splitting faces. For the cylinder, I have created the split lines in the same way as in the previous video. I have also made this file available for downloading in the description. Just roll the timeline back to just before the first loft to follow along. Let's create the bridging surfaces. Activate the Surface tab. Go to Create, Loft. Uncheck the Chain Selection option and select these 3 edges as a first profile. Click on the plus sign to begin the next profile. Set both continuity options to tangent and set them to align to surface. You will need to exercise your best judgment as to how to select the profiles. Experiment with different selections and see how the surface comes out. Let's perform the next 2 lofts. Let's create a patch surface to patch up the opening. Go to Create, Patch. Uncheck the Enable Chaining option and start selecting the edges that form the boundary of the opening. You can set the continuity option individually for each edge, or you can group them together and set a single continuity option for all. Let's group them. In this case, I have found that tangency produces a best surface. Do experiments with different continuity options for different design scenarios. Let's mirror the new patch surface across the right plane. Stitch all the surface bodies into one. From here, in order to use this surface body, we can thicken it. Go to Create, Thicken. Select the surface body and set the thickness. Another option is to build patch surfaces to cover up the openings. Make sure Enable Chaining is checked before selecting the edges. Finally, stitch all the surface bodies together into a solid. I'm curious to know how such a shape can be done using T-splines. Do let me know in the comments below.